Welcome. In this tutorial, we'll walk through the process of creating a truss from scratch. Whether you want to manually define a truss profile without following roof and ceiling planes or create one for another purpose, this guide will show you how. First, you need to create a project. To create one, refer to our YouTube channel or documentation page for reference. For now, let's jump straight into designing a single component truss. There are several ways to add a component in the layout. You can click the Create button and then choose Component. You can also use the shortcut Ctrl+Q, then select Component, or simply right-click anywhere in the scene to add one. Another option is to use this button and click Create New Component Design. Once the component insertion window appears, we can start defining the truss profile. In this window, you can set any profile you need. The first step in the process is basic shape definition. You can either choose a predefined shape or manually define the top and bottom chord profiles. For this tutorial, we'll define it manually. We'll create a simple truss with a 7/12 slope and a sloped ceiling. First, go to the length field and set it to 28 feet 6 inches. If you need help with input formats, check this table or save it for reference. This format applies throughout the software wherever length input is required. Next, define the top chord profile. In the distance field, enter half the overall length of the component, 14 feet 3 inches in this case. Set the slope to 7, making sure the correct unit format is selected, as there is an option to use degrees. Now, set the left and right heel to 1 foot each. Click Add Line, and you'll see the first line of the top chord appear in the scene. To add the second line, change the slope to a negative value so it slopes downward, then click Add Line again. You'll notice the right heel connects automatically. If you want a flat bottom chord, you can click the Close Profile option. However, since we're creating a sloped ceiling, we need to define it first before closing the profile. To define the bottom chord, go again to the distance field and enter 13 feet 11 inches and 8/16 to reach the middle of the truss. Set the slope to 3.5 and click Add Line. Notice how the profile updates. If you made a mistake inputting a profile, just click on the backup button like so to undo. Let's add the first line again and close the profile by changing the slope to -3.5. Once done, the software will move to the Shape Details step. Now we can modify the number of panels in any segment. Just right-click on any segment in the scene to add or remove panels. In this example, we'll set 3 top chord panels per side and 2 bottom chord panels per side. Once everything looks right, we can proceed with modifying other shape details. Since we already set the heels earlier, we'll leave them as they are. We will, however, change the left and right overhangs to square cut with a length of 1 foot 6 inches on both sides. We'll leave other settings like gable, jack, and piggyback unchecked since we're creating a standard truss. Click Next to move on to the final step. Now we will defining the structural details. Spacing is important for load calculations, so be sure to set it according to your plans. For this tutorial, we'll leave these settings as they are. You'll also find settings for load, analysis, and materials. These settings are explained in detail on our YouTube channel and documentation, so be sure to check them out as well. For now, we'll leave everything at default and click Insert to finalize the component. To verify that the truss was successfully added, check the Truss Explorer subpanel. The component has been added successfully, but note that it is still in an unanalyzed status. If you need to make specific adjustments, such as adding webs that are parallel, perpendicular, or point-to-point to a specific location, or changing lumber sizes and grades, be sure to check it out in our channel. Otherwise, let's move on to analyzing the truss. Click Analyze to proceed. If the truss passes analysis, its name will turn green with a note saying checks passed. Now, let's review the truss design drawing. To generate it, click this button and select Truss Design Drawing PDF. Opening the PDF gives you a full view of the truss profile, along with all relevant settings and information. You'll find details on loadings, wind and snow loads, max CSI values, member forces, and deflections. Load cases are also included. The software automatically generates essential notes as well. This document contains clickable links to help visualize different elements. If you want to view the full truss in Paragon, simply click or scan the QR code, and you will be directed back to the software. In this mode, design values cannot be modified as it is for viewing only, so feel free to explore. If you want more information about any aspect of the truss, it is simply a click away. For example, clicking this plate takes us directly to that plate in the software. That wraps up this tutorial. Thanks for watching, and see you on the next video.